Talked about vertical angles this morning, and vertical angles are the pairs of opposite angles. So this angle here and that angle are congruent, right? They are same measurement of the angles, and we can see that this angle and that angle are also the same, and we proved it earlier informally, because we already showed that this is a straight line here, and if this angle is given and the other angle should be supplementary to that, so together it should be 180 degrees. Then you can see another straight angle here, right? So this angle plus that angle should be also 180 degrees, which is supplementary. So then these two have to be the same. So that's how you prove that the vertical angles are congruent. Okay, now let's talk about perpendicular lines. We know perpendicular means 90 degrees angles, right? So if you have two lines intersecting and their intersecting angle is 90 degrees, then they are perpendicular lines. And let me ask you how you can construct perpendicular lines. Okay, I want you to consider that. And if you have a compass, take it out and think about how you can do it using a straight line. You are given a line. Mine is not very straight, so let me actually use the feature here. Okay, I have the line here. Let me see. Okay, it has to be both directions. If you are given a line like that, how would you draw a perpendicular line to this one? I want you guys to consider. So you can pick 2 points. So let's suppose you have point A and point B. You can pick any 2 points, and then you can use your compass. So let me bring it up here. Okay, and you're gonna make it a little bit bigger here. Okay, and let's see how it goes. Oopsie. And you can make circles. You don't have to make all the way, full circle. You can stop there, and you can bring the compass here on the other point, and with the same radius you can draw another circle there. So exactly same radius, you drew 2 circles, and as you can see, there are 2 intersecting points. One is here and the other one is there. If you connect them together using your ruler, so I'm gonna bring my ruler here. Come on, where is my ruler? It doesn't work. Okay, and anyways, you can connect those 2 points right here, and you can extend it. Let's see. You can do better with your pencil, I'm pretty sure. So if you are using your pencil connecting those 2 intersecting points, you drew another line, and that is perpendicular to the original line. Okay, that's how you can draw the perpendicular lines. Okay, and also a line is perpendicular on a plane if and only if it is perpendicular on every line from that plane. Lines there on this yellow plane, again, planes can be extended, right, any directions. So line AB is perpendicular to line T, so you can see between AB and T, it is 90-degree angle. CD and T is also 90-degree angle. Any line at this point here is 90-degree angle with line T. Then the line is perpendicular to this plane. Okay, so you can see that information too, the relationship too. Okay, so we are actually done for section 1, but I'm gonna give you some examples from your homework, so it can be helpful for you to complete your homework. Okay, before I explain any of these homework problems, I want you guys to consider first. Okay, solve the problems before you hear my explanation. Okay, which of the following is the intersection of segment BE and segment AD? So segment BE is right here, and that is perpendicular to the plane ADC, right? And segment BE and segment AD, consider these two segments. Do they intersect? They do not. So they are skewed line segments, right? So there is no intersection. Which of the following is the intersection of planes ABD and ACD? So let's look at ABD and ACD, two planes. Plane ABD is this side here, right? So this whole thing, that flat, and ACD is at the bottom, the base. So this base and the base, do they meet? Yes, they do. Where do they meet? So that and this plane, they meet at line segment AD, right? So line AD is their intersection. It is line because it says planes ABD and ACD, right? Planes can expand, so the intersection will be the line. Which of the following is the intersection of segment BE and segment BD? Segment BE and segment BD. By just reading it, you can see that point B is intersection, right? So BE is here, segment BE, and segment BD, BD. Okay, these two, this edge and the perpendicular line are meeting at point B. So that will be the intersection. Again, when you have two lines, they intersect at one point, right? And when they have two planes that are not parallel, then they meet at a line. Which pair of lines are parallel? BD and BC? I see already by just reading it. B is the intersection, so they are not parallel. AB, AD, point A and point A are both contained in both lines, so they are not parallel. They have intersection point A. AB and BC also has, B as the intersection point. And I don't see any other sides, any other faces are parallel to each other in this figure, right? Okay, which pair of lines are skew lines? Skew lines, they are not parallel and they do not intersect, right? AB and BC, I see that point B is intersecting AC and BD. Let's look at AC and BD. So line AC is in the back there, and BD is here in the front. And even if this drawing in mine looks like they are intersecting because I cannot draw on the three-dimensional, but this is in the front and green one is in the back, they do not intersect, right? So they are not parallel, so because they are not on the same plane, then they are skewed. BE and BD, I see B is the intersecting point, AD and CD, D is the intersecting point. The figure below is a rectangular box in which EF, GH, and ABCD are rectangles, and BF is perpendicular to planes, above planes and bottom planes. Use the figure to complete parts A through E. Again, I want you guys to pause the video and solve these problems by yourself first. Name one pair of skew lines. There are so many skew lines. For example, AB, line AB and DH, line AB and CG are skewed lines because they are not parallel. These two are not parallel, but they do not intersect, right? So this is one example, AB and DH. right? Or CD and BF, CD and AE, and so on and so on. There are so many pairs of skewed lines, and I want you guys to think about other than segment AB and DH as another pair of skewed lines. What is the intersection of planes EAB and BDH? Intersection of planes should be the line, right? EAB, EAB. Okay, if you connect this, it's gonna be triangle here, but if you expand it on every directional, it's the same as this whole thing here, A, B, F, E, right? So that plane on this side, this face, and PDH. PDH is PDH is this whole thing. So again, even if BDH shows only triangle, if you expand it, it's gonna be exactly same as this plane and expanded one, right? So we are talking about that plane and this plane's intersection. Then you will see that it will be the line BF. Okay, plane EAB, plane EAB is this plane. Again, we are talking about this plane expanded ones, okay? Is perpendicular to, it's perpendicular to what? Plane, above plane or bottom plane, right? So I will say to ABD. This is not the only answer. You can say plane PAD, plane PCD, plane BADC, anything, and bottom here too. You can use any of these 4 points, but in one order, in one direction. Whether you can say plane FEH or FHE or FGH or FHG, and so on and so on. Okay. All right. D. What is the intersection of line CD and plane EFH? Let me erase this and let's look at CD. Line CD is here. This line and plane EFH. EFH is the bottom one. So the base down here. What would you say? They are parallel, right? This plane and that line is parallel because you draw any line on this plane and that is parallel to this one because they do not meet at all, right? And also this line is here, this line and that line are on the same plane, so we can see that these two lines, line CD and line GH, are parallel. Then the plane that contains that line GH will be parallel to line CD as well. So there is no intersection. It's empty set. Explain why planes DCG. Planes DCG. It's so windy today, guys. Be safe. DCG is this triangle, but if you expand it, it's gonna be this plane here. And EAD. Where's the EAD? Is this one. So if you expand it, it's talking about this plane and more. Okay, you can expand it. So these two planes are perpendicular. Why are they perpendicular? Because it says rectangular box, right? Rectangular box means plane ABCD, because that's a rectangle. ABCD is a rectangle. Rectangle means rect, right angle. All 4 angles are right angle, 90 degrees. So this is 90-degree angle here, right? I'm gonna write that here. This is 90-degree angle. So this plane and that plane meets at 90-degree angle. That's why it is perpendicular. Okay, and this is a little bit tricky, so we're gonna solve this together. But again, pause the video and solve the problem. You are given measure of angle AOB as 1/3 of measure of angle COD. So we are given this information, and you need to figure out measure of angle AOB and measure of angle COD. Okay, so we know the relationship here. If this is an x, and this will be 3 times of that x. Or if this is y, this will be 1/3 of y. So you're gonna use either way, okay? I can use measure of angle AOB as x, and y can be then 3 times x, right? And we also know that this is perpendicular, and we have 90-degree angle, and this is straight angle, which is 180-degree angle. And we also know that angle addition postulate. So if you add measure of angle AOB, measure of angle BOC, and measure of angle COD together, you're gonna get 180-degree. So let me write that. Measure of angle AOB plus measure of angle BOC plus measure of angle COD using angle addition postulate, that has to be 180 degrees supplementary angle. Measure of angle AOB, we just said that it is an x, and BOC it's 90 degrees, and measure of angle COD is y, but y is also 3 times x. So 3x is equal to 180 degree. Because we know that measure of angle AOB is 1/3 of that, then this will be 3 times of the other one. Then we can solve for x. Now it's algebra. So 1x and 3x, 4x. If you subtract 90 on both sides, you're gonna get 90 on this side. Hold on. Oops. Where is it? Where is it? Wait a second, guys. I'm trying to expand this, but it doesn't work somehow. Oh, there we go. Alright, so we have okay, so we have 4x equals 90, and if you divide both sides by 4, x is whatever you get, that degree. Then what's y? Y is 3 times of x, right? So y is 3 times of x. So whatever you get an answer there, you can find 3 times of that answer. Plug it in. Okay, then you are good. Alright, that's it. And this homework is due Friday because we don't have Wednesday class. Okay, so make sure you do this homework and make the notes that is also due. So look at the email that I have sent you guys, okay? Alright, have a great day, guys, and I will see you guys on Friday. Thank you.